Everyone, welcome. First of all, I would like to welcome Dr. Graham Lao and Dr. Nazair Khaja. I'm so glad and so happy to have both of you here. Before we start, I would like to thank OPA. Those who are not from UMT, OPA is Office of Participants Affairs, and OPA deals with the students' affairs related to clubs and societies. So I'm very thankful to OPA for providing us this platform where we can actually, arrange different kinds of activities, where we can share information, and where we can arrange different kinds of events. So I'm very thankful to OPA and the head of OPA, Sir Khalid Naki. I'm hoping that he will join us today. So, Dr. Nozair Khaja is going to co-host this webinar with me. Dr. Nozair Khaja is a planetary scientist. He is an astrobiologist. He is working at Freie University Berlin. He is associated with many space missions, including NASA's Cassini space mission and JAXA's missions. He is also associated with the future Europa Clippers mission. So we are very happy to have you here, Dr. Nazair. I would like to call Dr. Nazair to help me welcome Dr. Graham here. So over to you, Dr. Nazair. Dr. Nazair, we cannot hear you. I think he is going to rejoin the webinar because he was unable to connect his audio. So let's just wait for him for a few minutes. Surprisingly, half of the participants are my students from school.
Can you hear me now?
Yes, yes, we can.
Okay, very sorry for the interruption because there is some issue with the connections. And thank you for the introduction. And I will quickly jump over to the introduction of Dr. Graham Lao. First of all, I would like to thank for his time to speak our students here in Pakistan. Just a brief introduction of Dr. Graham Lao. He is a cosmobiologist in a broader context, but in a practical context, Dr. Graham Lao is an astrobiologist. He is a communicator of science, and basic education that he had is a degree in biology and chemistry, astrophysics. He did his PhD in geology with a specialization on geochemistry and mineralogy. Currently, Dr. Lao is Director of Communication and Marketing of Blue Marble Space. Here, I would like to give you a brief intro of what is Blue Marble Space. It is a US-based international nonprofit organization that promotes cooperative exploration of space, examines life as a planetary processes, and enables a sustainable future on Earth. And Dr. Graham Lao is the very integral part of this organization. Dr. Lao is a research scientist at this organization as well. He hosts NASA Astrobiology and SAGA show, which is a very famous show on astrobiology, NASA astrobiology, that is Ask an Astrobiologist. I would recommend everybody, please do visit that. He is the research community coordinator as well for the Hypothesis Browser and the Life Detection Forums knowledge based. So these two, Hypothesis Browser and the knowledge base, these are the forums that everyone should visit and to see the work. Mainly, Dr. Lao is interested in determining the role that biology may play in the formation of rare minerals form, as well as what these findings may mean for the search for extraterrestrial life on other worlds other than Earth, such as on Mars and icy moons like Europa and Enceladus. So this is a very brief and quick introduction. And with that, I would like to give the floor to Dr. Graham Lao. And here you go. Thanks a lot.
Thank you very much for that introduction, and everyone for joining here in your evening. It is 7 o'clock in the morning here in Colorado, which is why we have this later time for you. Unfortunately, it's the best way to fit our schedule since I am on the other side of the world. I am going to share my screen here since I have some slides to go through. Hopefully everyone can see this screen with my slides on it. So let's discuss astrobiology and life in the universe. What I'll be talking about here, is it possible to turn off annotations, Rabia?
Yes, I can see the screen.
Yeah, if you can turn off annotations, that'd be helpful.
Okay.
Yeah, otherwise people will draw on my screen.
Ms. Sadaf, can you please turn off the annotation? I guess I don't have the right to do that.
I'm not quite sure how to turn it. Your students are drawing on the screen, unfortunately.
Wait a second. Let me just see if I can do it.
I will turn that off then. Unfortunately, some of you are annotating to present.
Actually, I think there are some students who are doing it.
Yeah, I don't believe from my end as a co-host that I can turn off the annotation.
Let me see.
Mm-hmm.
Is it working now?
I'm not sure. I'm gonna see. So if one of you who was annotating wants to try again, feel free. And we'll see if I turned it off or not. Yep, it's still on. So I guess the most I can do is just ask your students to stop annotating. Otherwise, all we'll see is their drawings.
Students, stop doing this, otherwise I would have to remove you from the session.
It should show you when they do it, who it is doing it. So that was Mudasir CH. Okay, well, let's try and see if we can get some here, and I'll just let you know who is annotating when they do.
Do let me know so I can remove them.
Okay. So one place I like to start off with is just speaking about our world, about the Earth. That is Ahmed Faiza is drawing. And so this talk mostly be about what astrobiology is. Astrobiology is the study of the origins, evolution, and distribution of life in the universe, which is, that's unfortunate. I think I'll just wait until your students are prepared to behave.
The host of Ma'am Sadaf, can you please turn off, change the settings of the session? You have made me the co-host, but I don't see any option here.
I'm trying to see from my side if I can find out how to turn that off. Yeah, I believe since I'm not the host, I don't have the capability to turn that off, unfortunately.
I have just called the administration and asked them to do it. So she's actually going to do it. So sorry about that.
That's okay. In the meantime, I had one person ask me if I've ever visited Pakistan. I have not. I would love to at some point. Yeah, unfortunately, I'm not seeing, so I am the host now. I'm not seeing this option that Zoom says I should have to disable annotations. So I do have a lot of very pretty pictures, but how about we just skip those for now? And Rabia, I'm going to mute you as well, just so there's no feedback in the background for me. So I will just speak about astrobiology then, without having the slides. So astrobiology is our quest to understand the nature of life in the cosmos, to know more, about who and what we are as living beings in this universe. For many of us, I mean, myself, I'm sure many of you included, have looked up to the stars at night and have wondered, are we alone? Is there something more out there? And this is something our ancestors long ago thought as well. They looked at the heavens, they saw the movements of the planets and the stars, and they wondered, is there more? What more is out there? And we've come so far now through our knowledge, through science and philosophy and our understanding of who and what we are. We've learned so much about our place in the universe. And to me, astrobiology is now this culmination of these things that we know, these things that we're trying to better understand about the universe and our place in it. And so when I was a young child, I had a lot of inspirations in my life, things like Star Trek and like Carl Sagan's writings and Cosmos and his television show, things that really kind of inspired me to become the scientist I would eventually be. And as Dr. Khwaja mentioned earlier, my research took me through biology and chemistry, astrophysics and geology. I did work studying phytoplankton in the ocean, in the Atlantic Ocean and Pacific Ocean. I did research on how we can understand organisms that can survive high up in the atmosphere. And I've done research in remote environments all around our world. And there's a lot that we are doing in the realm of astrobiology. And so even though I can't show you the slides, I can speak about some of these different things we're doing right now. There are people in the realm of astrobiology who are studying chemistry and biology and trying to understand the origins of life. And I say origins as a plural because we don't know yet how life started here on Earth. We don't know if life began in one single event or if there were several events. And it might be possible that life can arise a bunch of different ways. Maybe there are other situations on other worlds far away where life has arisen. And so we have to study the origins of life to see how the building blocks of life as we know it, the basic chemical molecules that come together to make living things, can form biology, can start to act as a living system to create worlds like ours. There are people in astrobiology who are studying the history of the Earth by looking at things like the chemical signatures left over in the rocks to try to understand the history of our world, how life and the geosphere, how the rocks at the surface of our planet, how our atmosphere, how they have evolved together through time, how they have changed together through time. A lot of us are interested in things like planetary impacts, when asteroids and comets strike the Earth, what those things do to life, as well as what those things might have meant through time on Earth for delivering chemicals from various parts of the solar system and beyond to the Earth. I grabbed just for fun off of my shelf a few of my meteorites. This one right here is a Chondrite Meteorite. This is a primitive rock that actually formed before our Earth very long ago. It has inside of it little metal flecks called chondrules. These are formed just before the planets started aggregating and forming inside of our solar system. These meteorites also have things called calcium aluminum inclusions. These are the very first solid minerals that formed inside of our solar system. But one of the really cool things that I love a lot about these meteorites, they're called primitive meteorites, is that they have things inside of them called pre-solar grains. These are little flecks of carbon, graphite, diamond, very small minerals that came to our solar system from other star systems long, long ago, and then merged into the material that was forming our solar system. And it's one of the things about the periodic table that you don't often hear. The periodic table should be the same throughout the universe. If an alien civilization is smart enough to develop science and start learning about chemistry and the similarities between atoms and atomic chemistry, they should make roughly the same table. But one of the differences would be that normalized atomic weight that you see on a periodic table. That atomic weight is actually based solely on the chemistry of those elements here on Earth. It's based on the abundances of isotopes of elements here on our planet. But these pre-solar grains, they don't match those isotopes. And so periodic tables from other solar systems, other star systems far away, would have slightly different atomic weights if they use a normalized, an average atomic weight on their periodic tables, which I think is pretty groovy. Just for fun, I also have a piece of the moon right here. This little meteorite, it's a small fleck of rock right there in the middle of my camera. That little itty bitty piece of rock, it comes from Morocco, near the border with Algeria. This is one of the many lunar meteorites we have in our collections. One thing I'm interested in as an astrobiologist is not just how rocks got launched off of the moon and came here to the Earth, but also how maybe long ago rocks bearing some of the very first organisms from our planet might have been launched off of the Earth and landed on the moon. And so maybe a good reason to go to the moon is to look for possible signs of life or ancient Earth life in rocks, in meteorites from Earth on the moon. There could be a little safe of rocks somewhere on the moon for us to find, housing the Earth's earliest life forms. And the same could go for other worlds as well. So let's talk a bit about some other worlds in our solar system. You might have heard about a recent finding with Venus, which has made a lot of popular news around the world. Recently, some astronomers have suggested a detection of a molecule called phosphine in the atmosphere of Venus. Phosphine is a molecule composed of phosphorus and hydrogen, and it's extremely rare here on Earth. Actually, it doesn't form naturally anywhere on our planet without life being present. So on the Earth, when we form phosphine in the laboratory, we can do it without life. We can do that chemically. But otherwise, to find phosphine on our planet requires the biology, requires living things acting. And that's one of the reasons why that phosphine finding was so intriguing on Venus. But we don't know yet if that was real. We still have to confirm this finding and figure out if there really is phosphine there. And so we have other people right now who are using other telescopes to look for it. There's also some upcoming missions that might look for phosphine on Venus. The Bepi-Colombo mission from NASA is currently on its way to Mercury to do some research, but it has to fly by Venus one more time next year before that happens. And during that flyby, it could look for that phosphine on Venus. There's also an upcoming commercial space mission from Rocket Lab using their Electron rocket, where they try to send a mission specifically to look for this phosphine on Venus and for looking for signs of life on Venus. And so Venus is a very intriguing world. And personally, when I think about long ago in our solar system, if there was any other world besides the Earth that most likely had life, it was probably Venus. Because Venus is very much like the Earth. It's very close in size and density. Its core isn't as big, and it doesn't have a nice moon like we do. But in its early history, it may have had oceans and a large atmosphere, and it might have had a biosphere. But then some time ago, between 500 million and 1 billion years ago, it appears that most of the surface of Venus melted and became magma, became lava at the surface. And the atmosphere of Venus has experienced what we call a runaway greenhouse effect. And so the surface temperature on Venus is about 460 degrees Celsius. And it's about 92 times the surface pressure we have here at the Earth. And so if you were to go under the ocean in a submarine, if you go down 1 kilometer in the ocean, that's about the pressure on the outside of your submarine that you would feel at the surface of Venus. And so the surface of Venus is very hot and very inhospitable. But the cool thing with that phosphine finding is that it comes from a place in the clouds of Venus, in the atmosphere, where the temperature and the pressure is actually far more clement, something far more likely where life could actually thrive. But there are other worlds to consider as well. We also have Mars, also known as the red planet. Mars has been a fascination for many of us throughout human history. Looking to the sky at night, Mars appears red to our eyes because of the way the light from the sun interacts with the dust in the Martian atmosphere. And even when you look at pictures of Mars, it looks pretty red. It's kind of more of a brownish looking color from orbit using visible light, but it is very much kind of a reddish color because of the oxidation of iron on the surface. Iron metal on the surface of Mars is rusting. And that's called oxidation. Much like we have here on Earth, if you have an old piece of metal sitting outside and it gets rain on it over time and is exposed to the air, eventually it might start rusting. If it doesn't have a good coat of paint, it can start to rust. And that same thing is happening to the rocks on the surface of Mars, which is why it's so red and brown in coloration. We've sent lots of missions to Mars. And in fact, we've sent more missions to Mars than any other place outside of our own Earth so far. We've sent dozens and dozens of robotic missions to Mars as orbiters, as flybys, as landers, as rovers, and here soon, even as a drone. You might have heard this year, we now launched 3 new missions to Mars this summer. So NASA launched what's called Mars 2020, which is carrying along with it the Perseverance rover, which a lot of us are nicknaming Percy. And on its back, it has a helicopter, a drone called Ingenuity that will fly around and do some science as well. And Perseverance will be the very first mission to try to collect samples at the surface of Mars for later sample return, which would be a holy grail of sorts, an important thing for us to have in astrobiology, because when we have samples from another world, we can do so much more work in our laboratories here on Earth than we can using our robots there. So sample return is really huge. But there were also 2 other missions launched this summer. The HOPE mission from United Arab Emirates is their very first mission to Mars. It was actually built just down the road here from me in Colorado. And this mission is an orbiter. It will take really beautiful photographs of Mars. It will do some chemistry, some spectroscopy, trying to understand the chemistry of the Martian surface based on the way the light interacts with the rocks. And there's also another mission called Tianwen-1, which was launched by the Chinese National Space Agency. And Tianwen-1 is a pretty ambitious mission. It's going to have an orbiter, a lander, and a rover, all 3 in one. And it's currently also on its way to Mars. The idea being to begin orbiting, find a landing site, and then to land this lander, and then off the back of the lander, the rover will drive out, much like their recent missions to the moon with the Chang'e missions. And so there's a lot of exciting things going on here for the future of Mars. And a lot of us in astrobiology are preparing for what we might look for in places like Venus and Mars and other worlds by doing research right here on Earth. There are environments all around our planet that provide us with analogous, not the same, but analogous, similar systems to study, ways that we can study how life interacts with rocks in, for instance, rusty rock systems. So I mentioned how the rocks on the surface of Venus are rusting and turning red. We have places around the Earth where that's happening as well, like in the Atacama Desert, the driest place on the planet in Peru. In this desert, there are organisms that can survive in extremely dry desert conditions around these rocks that are a very good analog for Mars. There's another good system called the Rio Tinto River in Spain. In this system, we have what's called acid rock drainage occurring, where waters and rock are interacting and creating highly acidic fluid and very iron-rich fluid. And so we see these really beautiful blood red colored waters coming out of this river. Also, I've done research in a place called Borup Fjord Pass up in the high Arctic near the North Pole, about 500 miles south of the North Pole. And in this place, there's a valley where we find these large red geological structures, kind of like big circular caps on top of hills. And these caps are something we call, in the mining terminology, gaussens. And this is a term, it's also sometimes called an Eisenhut from the German, or a red cap is another name for it. These are caps where ores rich in metals in the subsurface are interacting with water and the air and forming that same rusty material. And so we're studying that as a way to better know what we can look for on Mars with our upcoming missions and missions that are yet to be dreamed of. But there's also other amazing places out there in our solar system for us to consider whether or not there could be living things. You might have heard of Europa, for instance, one of the Galilean moons. I hope you had a chance. I'm not sure what your weather has been like in Pakistan here of late. But on the winter solstice, we had a grand conjunction of Jupiter and Saturn coming together close in the sky. And with a really good pair of binoculars or a decent telescope, you could actually see some of those larger moons of Jupiter and Saturn together. One thing you don't hear about often is that the Galilean moons, the ones that Galileo first discovered in 1610, those were the very first moons beyond our own moon that we humans ever discovered. Those 4, Io or Io, Europa, Ganymede, and Callisto, are the 4 largest moons of Jupiter. Ganymede's the largest moon in our solar system altogether. And they're large enough that you could just see them the other night. And actually right now in the sky, Jupiter and Saturn are still very, very close to each other. It's still very beautiful to see in the evening right now after sunset. And with Saturn as well, Saturn's largest moons are also visible. Its largest, Titan, is also visible with a good pair of binoculars. I could see it with mine. Titan was the 5th moon discovered outside of our own moon. And so right now in the sky together with a pair of binoculars or a telescope, you can see these amazing structures. And several of those moons are intriguing for us in looking for potential signs of life out there. Europa, one of those Galilean moons, it's about the size of our moon, but it's also gotten rather famous in the search for life because Europa has this beautiful icy crust on the outside covered in cracks where the ice breaks and fractures the same way ice and icebergs and ice sheets here on Earth fractures and moves around, and glaciers and kind of how it moves around. But based on our data from spacecraft, we have very good reason to suspect that there's a very, very deep ocean underneath of Europa's ice, where that icy crust may be some 10 kilometers thick. There could be an ocean down below somewhere in the range of 100 kilometers in depth. Now, if you don't know, the average depth of our oceans is around 3 kilometers. And the deepest parts of our ocean don't even go down much more than 10. And so this is very, very deep and what we call voluminous. There's a lot of volume of water inside of Europa's ocean, which makes a lot of us wonder, could there be a living biosphere down inside of that ocean? On the bottom of Earth's oceans, we've discovered hydrothermal vents, these hot chimneys of fluid coming out of the subsurface and providing oases for living things to thrive. Things like giant tube worms and microbes of all forms, albino crabs. There's so many things that dwell in these oases on the ocean floor. And if Europa has those hydrothermal vents as well, it may also have chemistry from the surface interacting that could allow for a biosphere to form there. And so it's good reason for us to go there and to look for more signs of potential life. Right now, we have an upcoming mission called Europa Clipper, which intends to do just that. It will go in orbit around Jupiter and Europa together, and it will try to study the surface of Europa to see if there could be signs of chemistry from the subsurface, if there could be signs of life around. And so we're going to be looking for these things. There's also a mission called JUICE, or the Jupiter Icy Moon Explorer, from the European Space Agency upcoming. That one will also be looking at the icy moons of Jupiter, primarily Ganymede and Callisto, but also looking at Europa. And so there's a lot of intriguing science coming up. I also, in my show, Ask an Astrobiologist, I was recently very lucky in that I had a chance to speak with the deputy principal investigator for the mission called Dragonfly, which we're looking to launch in the next decade. Dragonfly is a mission that's going to go to Titan, that 5th largest moon that I mentioned that you can see right now in the sky. And Dragonfly is going to not only be a lander that lands on this moon, it's also going to have 8 propellers and be a drone that can lift off and fly around and do chemistry and try to understand if there could be life there, to try to understand the ice, to try to understand the organic molecules. So Titan, as a moon, has one of the thickest atmospheres in our solar system. Titan has the only major atmosphere for a moon, and its atmosphere is so thick that if you were to look at where the International Space Station orbits our Earth here, in that same orbital position, that distance away, it would still be very much inside of Titan's atmosphere because it's so thick. And it's very dense. At the surface, it's about 1.5 times our surface pressure. You might have heard before, for instance, if you were to take a pair of large cardboard box wings and just flap your arms, you actually could fly at the surface of Titan because the atmosphere is that dense. However, it is extremely cold. It's about the same temperature as liquid nitrogen, very close to it, and it's covered in organic goop. So here on Earth, we have what we call a methodological cycle. This is a hydrological cycle, sorry. This is where water in our rivers and our oceans, our lakes, in its liquid form can evaporate and become gas. And in the sky, it can condense and make clouds. and it can precipitate down as rain and sleet and snow and hail and these other features. Well, on Titan, there's a methodological cycle. So molecules like methane and ethane, things that are composed of carbon and hydrogen solely, they can evaporate from Titan's surface. They can go up into the atmosphere. They react with sunlight, even though it's so far away, the sunlight can cause these molecules to react and make a bunch of other hydrocarbon molecules and various organic goop that we call tholins. And this organic goop then rains back down, and the organics themselves can make ices and form things like sand. Here on Earth, we have sand dunes. On Mars, we've seen sand dunes. On Titan, there's sand dunes, but they're not made of the rocky dust like we think of here on Earth and Mars. Instead, the sand dunes on Titan are formed from ices of hydrocarbons and water and other molecules. And so it's very worth our time to go there and explore. But there are certainly a lot of other places where we're looking for life as well now. So many of you are young enough that during your entire lifetimes, we've known of worlds around other stars. But when I was born, we didn't have any confirmation of other worlds. It wasn't until the mid-1990s when we first started discovering those first worlds around what we call main sequence stars, stars like our sun and most of the other stars out there. These exoplanets are providing us with so much more opportunity now to look for potential signs of life in the universe. We now know of over 4,200 exoplanets. And I would wager by the time that most of you are becoming older people that we'll have at least 100,000 or more exoplanets that we know of. And we've now started doing some science looking at the chemistry of their atmospheres, of these worlds around other stars, using things like our current telescopes, the Hubble, and using radio arrays here on the Earth. We've done a lot of research, but we have upcoming telescopes as well that are going to help a lot in this mission of looking for potential life out there. For instance, the James Webb Space Telescope, which hopefully will launch next year, is one of the ones that will be able to look really well at the atmospheres of exoplanets at nearby stars. There's also several other next generation space telescopes, several missions like LYNX, the Origin spectrograph that's been planned for some time now, a few other missions that could be developed to help us look at exoplanets and try to understand whether or not there could be life out there. And there's also a whole other realm of astrobiology, not just looking for potential signs of life, but looking for signs of technological or advanced or intelligent life. You might have heard of SETI, the Search for Extraterrestrial Intelligence. There's a new term that's very common now in our lingo called Techno Signatures. Techno Signatures are signs of technological activity. Here on Earth, back in the 1970s and 1980s, we, in our industrial applications, had developed a large number of compounds called chlorofluorocarbons, or CFCs. They were in everything. They were in spray cans for hairspray and for body spray. They were in air conditioning units. They were inside of automobiles. They were used everywhere. But we realized, thanks to space exploration and having satellites looking back at the Earth, that we were developing a hole in our ozone layer that had the potential to not only change our planet's climate, but also to threaten life on Earth and threaten our life specifically. And so a lot of governments of the world came together and said, no more CFCs, we're going to ban them. They made a clean air treaty or clean air pact where they decided to get rid of these chemicals to the best of their ability to try to save the ozone layer. And it was a very important moment for us around the world for governments to work together to make this happen. Well, we now can look out using our telescopes at other worlds and see if maybe they're doing something similar. Are they also changing their atmospheres with industrial molecules? Are they creating things like chlorofluorocarbons or other industrial things that would be signs of technological activity? Might we also find signs of radio waves or other emissions of energy, of wavelengths of light from their worlds? For quite some time now, over a century now, we here on Earth have been broadcasting messages to space. Most of it we haven't intended to. It's just part of how we broadcast our television and our radio signals around the planet. So messages from the Earth, from old television shows and movies, have been traveling out into space for a very long time and have actually passed thousands of potential worlds. And so who knows, maybe out there's an alien species right now that's been watching our television and listening to us talk in our radio. And that'd be really intriguing. You might have just heard, just recently it was announced that late last year, there was a detection of a confined radio beam source from the nearest star system, Proxima Centauri. And currently the Breakthrough Listen project at UC Berkeley, Berkeley SETI program, are trying to understand what this radio signal might mean. Could it be a sign of extraterrestrial intelligence? However, many of us are remaining skeptic. We don't know what it could be. And usually when we hear these radio signals, they end up being something from our planet, an interference, or something from in our solar system. But there could be messages out there for us to listen to. And who knows how many extraterrestrial civilizations might be out there right now just waiting for us to join the group of interstellar species in our universe. There's so much more for us to explore. I did have a lot more in my presentation about careers in astrobiology and potential opportunities, but I think I'll cap it here since we have been in the meeting now for some time to allow for questions. So I will turn the chat back on. So I think that should be back on. And I do apologize to those who would have liked to have seen my slides. I am happy to share images of everything I spoke about and far more. Many of you may have heard from Rabia that she joined me this past summer at Blue Marble Space Institute of Science as an intern. She worked in our Young Scientists program, a program where we bring students from around the world. We had 66 interns this year from 21 countries, and students from around the world can join us to do research with our scientists in a variety of projects. I have projects that explore science communication. I had a project this summer that was working with NASA and developing this knowledge base of biosignature understanding. There's other projects on understanding planetary nitrogen cycling, on using computer modeling to do the carbon budget estimation for a company. We have a lot of these different projects. Some of them are in complexity understanding or ecology. We have projects in geochemistry and origins of life at the Earth Life Science Institute in Tokyo in Japan. So there's a whole bunch of these different projects. And if you're interested in the projects, they're currently not open for high school students, unfortunately. They're only open for undergraduate university students or those who have recently graduated from university. However, for those who are later in their career or those who've completed the program, like Rabia has, they can also join some of our scientists as visiting scholars, which Rabia has now done. She currently is a visiting scholar with Blue Marble Space Institute of Science, which gives her the opportunity of doing research with me, but also in being connected then to our larger community of astrobiology researchers and science communicators and professionals in this realm of space exploration and Earth science. And I do see some questions coming in here, so I'm going to try to see if I can read any of them. Can I say Lahore, Lahore, I? Here's one from Umar. Can we live long on other planets? The answer is no. We in our human form, as we currently are, we did not evolve to survive in our bodily form on other worlds. We've evolved to fit our world very much, to fit our Earth. To go to another world and to walk on the surface. So say we go to Mars. To walk on the surface of Mars, we need a spacesuit because the average temperature on Mars is extremely cold. And the atmosphere is very, very minuscule. There's no air to breathe in, and there's almost no oxygen anyway for you to breathe in. And so to live on Mars, we would need to have spacesuits and habitats and things like this for us to survive. And even when we go into space in orbit of the Earth on the space shuttle, the International Space Station, the Soyuz rockets, the Crew Dragon, when we go into space, we need to protect our bodies. The space station really is just a very big space suit. It's a spacesuit that fits multiple people. But to go outside of the space station, we still have to put on spacesuits because we just can't thrive. You would live for a very short fraction of time if you were actually exposed to space. Primarily the cold would be the worst part. The vacuum would suck everything out of you, but your body would almost instantaneously freeze because the temperature of space in most places is around 4 Kelvin or so, which is extremely cold. And so space is not meant for us. Other worlds are not meant for us. But through science and engineering, through learning how to solve problems, we can learn how to send people to these other worlds, these other realms, and explore. So maybe not the surface of Venus, that'd be really hard for our spacesuits to work, but the surface of Mars, the surface of Europa or Titan, Enceladus, perhaps. And who knows what we have in our future. As a huge fan of science fiction, in novels and television and movies and video games, I like to dream about what might come for our species in the near future. Ooh, I see one, like the movie After Earth. Yes, After Earth was an interesting one, where Earth evolved after humans left and went to live on Mars and had changed Mars, terraformed Mars, as we call it. Terra, coming from the word for Earth, and then form, to change. And so terraforming is changing a world to be more Earth-like. And it's been a dream of science fiction and of science for a very long time that could be possible. Let me see what else I can see here. There's a bunch of questions coming in here. Hassan, I really want to be a scientist and working hard for it. That's wonderful, Hassan. Please keep working hard for it. You can be anything you want in your life. I started calling myself an astrobiologist long before I had a PhD. What you choose to do in your life, you need to find something that you can work for, that will give you a payment, a salary to help live your life and provide for the things you want for your family. But having something in your life that also you can be passionate about and can inspire you is extremely important. And also having hobbies is great. Behind me, I have my collection of meteorites and rocks and fossils, gems. I have my guitars, my didgeridoos. And also I like to lift weights, I like exercise, and I'm really into meditation and teaching meditation and martial arts as well. And so there are lots of things you can do in your life that will give you passion and help you to better understand yourself as a human being, as part of your family, as part of your community, as part of your nation, and as part of the world. And so I highly recommend doing everything you can in your life. And if you want to be a scientist, that's awesome. If you don't want to be a scientist, that's also awesome. There's so many things you can do. And if you want to be involved in astrobiology, you don't have to be a scientist. You can study science or study engineering, but you could also study business and be involved in astrobiology. You can study law. We need space law right now to understand, should we protect Mars from Earth life, potentially killing Mars life? What kinds of treaty should we have at the international level to understand what we're going to do when humans go to Mars? You can be an artist or a musician or a poet or a writer and be involved in these endeavors to better understand what it means to be a living being in this cosmos. Let's see, I have a few other questions. Ayan Malik, I want to go to space. Can you give some advice? I want to go to space too. It's been a dream of mine since I was a kid to become an astronaut. And those doors are opening more and more right now for all of us around the world. So for a very, very long time, the people who went to space were mostly American or European or Russian, even though some of Russia is in Europe, but we're Russian. And we're mostly men who had been in the military in these various areas. And that's changing right now. Now there are astronauts from other nations from around the world who've gone into space, but still less than 600 people have actually gone into space so far. And we need to change that. And so there's a bunch of things that are happening right now in space exploration that are helping us to do that. There's a group that I really care about a lot. I know a lot of the people working for it, called Space for Humanity. At Space for Humanity, they're bringing in investment money to support sending private citizens from around the world into space with the mission of sharing the story of space exploration with other communities from around the world so that we have diverse perspectives from different places, from different people, from different backgrounds. And also right now with companies like SpaceX and Blue Origin and Sierra Nevada Corporation, all of these private companies coming up, they're making it more likely that we're going to have a lot more private citizens and space tourists going into space very soon. And so I'm looking forward to that as well. I think that's going to be my opportunity, and it might be yours. In preparation for that, a few quick things you could do to start getting ready. One is to read about the history of space exploration. read about what astronauts do in space and how they prepare. Some other things you can do is get good at running and swimming and take care of your overall fitness. Astronauts need to be fit to make sure their bodies will be okay going into space. I personally recommend meditation for having better control of your emotions. One thing about astronauts that you might have heard is it's called the right stuff. This idea that the early astronauts had the right stuff to be able to be calm under pressure as their rockets were lifting them into space. And I highly recommend meditation and learning about the history of meditation to help you control your inner self. Because when things are very exciting or very scary around you, being reflective on those moments is the best way to survive through them, in my personal opinion. Other things you can do is learn about flight and how to fly. You can learn about scuba diving and the history of undersea exploration. You can learn about how humans survive in extreme environments around the world. And you can look up potentially how to live in a Mars analog base. So I've lived in one in Utah called the Mars Desert Research Station. We now have a bunch of them around the world. These are places where we can act like we're living on Mars to understand more of the psychological impacts on humans when we're locked in these little environments together. Ooh, I see someone said that they meditate once a week. I love it. Meditation is beautiful. I meditate every morning, and it's a very important part of my life. Mahad Saeed, is there life on another planet except Earth? Well, we don't know, and that's what we're looking for. If we do find life on another planet, people like myself, astrobiologists, we will have jobs for sure. So that'd be job security, they call that. But it's a thing that I've wondered since I was a child, and I'm sure many of you have wondered as well. Is there life on other worlds? And if it is out there, what does it look like? What does it act like? Is it something like we've dreamed of in our science fiction, our stories? Or is it something really entirely alien? We only have a little bit of time here left, and so I'll share one other quick story from my slides. Unfortunately, I can't show you the picture. But one of my favorite creatures on Earth is called the Greater Wax Moth. It's a very tiny moth, lives in a bunch of places in Europe and Africa, Western Asia. This moth is alien to me and to you, most likely, for a very good reason. So you most likely have seen moths and butterflies, or at least know what they are. But this moth has the greatest range of hearing of any creature on our planet. So we humans, we hear around 2 to 5 or so hertz. That's waves per second. And so if I hear 2 hertz, which is a very low bassy sound, goes very low, that'd be just 2 waves coming at my ear every second. So that's not too bad, but we also hear up to about 20,000 hertz, or 20,000 waves of sound per second hitting our ear. That's really, really, really fast. So fast, I can't move my hand 20,000 times in a second to show how quick those waves are hitting our ears. And those 20,000 hertz, that's a very high-pitched squealing sound that older people like myself can't hear anymore. The younger people in our audience, you can probably hear 20,000 hertz. Most of us who get older, we start losing some of that higher range. I personally hear around 17,000 hertz now. And when you're very old, you usually go down to about 12,000 hertz. But some other animals hear better. Dogs can hear to 50,000 hertz. Dolphins and bats that use echolocation, they can hear well past 100,000 hertz. But the Greater Wax Moth, its range of hearing allows it to hear out to 300,000 hertz. Now, if you want to know what that is, that's actually at the level of hearing our radio waves. So if you're ever in an airplane or you see an airport, at the very end of runways at airports, there's a little beacon, a little light that flashes. It's one thing that allows pilots to know where the end of the runway is, but it also has a little radio inside of it that's always transmitting signals to the airplanes, for the aircraft all around our skies. That signal is in the radio range that the Greater Wax Moth can hear. And so this moth can hear that sound of our airports. But what's really alien about the Greater Wax Moth is that it only hears from 50,000 up to 300,000 hertz. So remember, we hear about 2 to 5 to 20,000, and it hears 50,000 to 300,000. So out here, I can't stretch my arm that far. So that means that not only can we not understand, our brains can't process what it is like to hear what the Greater Wax Moth hears, But the greater wax moth can't hear anything that we hear. It can't hear my voice right now. It couldn't hear the sounds of our lives around us the way we do. And that's alien. And so even here on Earth, we have some alien things that can teach us more about what it means to be living on this world. And I think I'll end it right there, Rabia, unless you think there is time for more questions.
Only if you have time, otherwise I think we are good to go.
I'll scan through here real
There are
quick.
some Sorry?
I'll scan through here real quick.
Yes, sure. There are some university students as well.
Oh, wonderful.
Science
Well,
schools.
please do
Yes.
check out the Young Scientist program. Our Young Scientist program is always evolving and adapting. Some of the projects are funded and can pay. Most of the projects, unfortunately, are not funded, but they are a great opportunity to be involved in research and to find our larger organization, our larger community.
So I guess that's it. Thank you so much, everyone, for joining us today. Thank you so much, Dr. Graham, and I'm really sorry for what happened in the start.
That's okay.
Dr. Nazair, would you like to say something?
Thank you very much, Dr. Graham Lao. This was really interesting. Much appreciate to talk to Pakistani students there. If you have only a few seconds, I have a very practical questions, 2 questions that will really impact, and this is the purpose that we have to conclude at the end. Of course, the science communication is one thing, but we are aiming for to diverge the research of astrobiology in Pakistan and to make some kind of bridging. So what could you offer from the BMS platform, although you have said already, to provide the thesis kind of things, virtual thesis, in which field the students should come up and we should redirect towards you, towards BMS, for example?
Absolutely. One, I do invite all of you to watch my show, Ask an Astrobiologist. During every episode, I speak to another astrobiologist about their research, but I also really like to talk to them about their careers and which fields they studied. I mentioned earlier, actually Dr. Nazair mentioned, I studied biology, chemistry, astrophysics, and geology. But you don't have to do all of that to be an astrobiologist. You can just study biology. You can just study astronomy. But you can also be involved in astrobiology by studying medicine. We need to know, there's a realm called bioastronautics. We need to know how our biology, how our physiology is impacted by being in space. And so you can study medicine and still be involved in astrobiology. Like I mentioned, you can study law, you can study philosophy, you could be a writer or a painter and still be involved in astrobiology. But if you do want to be involved in the research, if you want to be involved in the research projects that are going on, then it really is crucial that you do study science and engineering. Math is important. You don't have to be the best at the math in the world to be involved, but math is the language with which we communicate through the sciences and through engineering. And it is important to have an understanding of it. For those who need better math, I do recommend Khan Academy online. They're free and they have wonderful lessons throughout the realm of mathematics and in many other places that can help you to study there if you're interested. For university students, if you are studying in science and engineering, that's already a great place to be if you want to be involved in doing astrobiology work and in getting involved in this community. But please do remember, you don't have to have a degree in astrobiology. You don't have to take a class in astrobiology to be involved. Many of us don't have those things because there's only a couple of programs in the world that give degrees in astrobiology. And most of the astrobiology classes are online classes that are wonderful. There's one from Charles Cockle, for instance, which is on Coursera that I highly recommend. It's had tens of thousands of students now, and it's a great introduction. But to be involved, you really just need to be involved in the process of science, of thinking scientifically, of learning how to ask questions and how to be humble when you accept the answers. Sometimes the answers you find won't be the ones that you thought you would find or the ones that maybe you wanted. And that's an important thing. We have to be brave and daring in the kinds of questions we ask, and we have to be humble and accepting in the kinds of answers we receive. And that allows us then to work together as a global community in our research. And honestly, as we said when this meeting first started, someone asked if I like virtual meetings. And my answer is resoundingly yes. I do miss being near people. I would love it if all of us were in a room right now together. There's a different energy we have and a different psychology and sociology we experience when we share a physical presence together. But because of the pandemic and the way things have been, we can't do that right now. But in a little glimmer of hope, I've noticed I'm now speaking to people from all nations around the world, and people who are getting excited about astrobiology and space exploration and philosophy and meditation, and who want to have conversations through these virtual meetings. It's allowing us to connect around the world. I mean, you are literally 12 hours away from me right now in time, and yet we are connecting right now, and that's really beautiful. And I think for all of you watching, it means that the opportunities for you are going to be far more open than they have been in the past. You'll have opportunities to reach out to other people and speak to them. If you are a university student and want more information, we're going to release the projects for the Young Scientist program in February, but there are also other programs, and some of them do accept international students. I know it is very hard. One question I get a lot from international students is why can't they apply for internships through US institutions that are funded by NASA? And the unfortunate part of that is that NASA is a government-funded organization. And because of that, the US government won't allow NASA to fund international students for most things. There are a few exceptions. There is an international student fund through NASA for working with NASA scientists that I do recommend you look at, but many of them don't allow that. But that said, Blue Marble Space Institute of Science is not the only space exploration organization on the planet. There's lots of others. I highly recommend checking out all these organizations and the good things they're doing. Tune in for their webinars, their lectures, and try to learn more about what's going on in our world. The Space Generation Advisory Council is a group of young people from around the world who are advising the United Nations on how to proceed with space exploration. And it's full of a lot of great people who could be your colleagues in the future in being involved in this endeavor. And I also recommend looking at things like Space for Humanity and some of these other groups who have lots of webinars where you can hear talks from astronauts. I personally have moderated panels for Explore Mars. We had one where we had a bunch of panelists talking about how we're going to feed astronauts on Mars. And so there's a bunch of really cool things you can do like that. I know that was very long-winded. I apologize for the long answer.
No, thanks very much. This is really interesting. I mean, the students from different backgrounds, they wanted to hear what you just explained, and they got a lot of answers to their questions. And just with the last note, I really would like to, as I said, to bring the astrobiological research here in Pakistan, whatever the resources we have here in Pakistan. We don't have any space mission, of course. We don't have direct connections in Pakistan with the persons who are really doing laboratory works or directly connected to the space missions. But whatever we have here in Pakistan, I really would like to kind of make a collaborations through such kind of seminars where we can show to the international community what we have, and then the persons like you can come up to suggest us, okay, this is your resources in your country, and you can do such kind of things for space exploration or for astrobiology. So this should be the very interesting for university level students and for researchers to do that in Pakistan.
Yes, entirely. I think that's entirely possible. And I also want to remind everyone that the greatest resource is you. It's your talent. It's your skill. It's what you know about yourself. And remember, every single person you meet on this planet, every single person knows at least one thing that you don't know. They've experienced at least one thing that you have not experienced. And so even you don't have to have a space agency to be involved in space exploration. Many people around the world are showing us that now more and more. And your talent, your skills are what will set you apart. If you have questions, if you have ideas, don't be afraid to ask questions. Don't be afraid of someone else thinking that your ideas are bad. And sometimes you're going to have some bad ideas, but I swear to you, I promise you, at least one of your ideas is good. At least one thing that you think you want to do, at least one thing you want to ask is good. And it will help you to advance yourself further. And by allowing yourself the freedom to accept that, to be willing to ask questions, to be willing to accept answers, it allows you to be freer then to continue that process of getting involved, of asking questions, of learning more, and of becoming involved in this global community of people who are right now trying to figure out, are we alone in the universe? Where did we come from? What can we learn about our place in the universe? And these are very important, big questions that involve all of us and require all of us.
Thanks a lot. And I think I don't have any more questions. And Rabia, I think if you think that we can end the session.
Thank you again for joining the first webinar. Thank you so much, Dr. Graham, for the wonderful presentation. And I'm again very sorry for what happened in the start. And I will make sure that I have all the rights next time in the next meeting, so I can control what is happening here. And I would also like to thank Europe, who is joining us today from India. So I guess that's it. Thank you so much, Dr. Nazair, for joining us. Thank you so much, Dr. Graham, and EA for arranging this webinar. Hopefully, there will be other webinars like these in future. Graham, can you end the meeting? You are the host.